Thank you. Alrighty. So hello everyone, I'm Chris Harris. I'm one of the team leads of the Supercomputing Applications team at Pawsey. Our team helps researchers when they've got something running on their laptop or institution that just doesn't fit anymore and needs to be scaled up onto the supercomputer, and we work with them to migrate their workflows and help them scale up. So this module is looking at an overview of the file systems. So this is where we're staging our data onto the supercomputer, ready for actual use with compute work. So coming out of this, you'd hopefully have some idea of what a file system is and what the purposes of the various file systems are on Photonics and how to use them, and also have an idea of monitoring your usage of the file system to have an understanding of how much of it you're using. So, file systems. You would hopefully be familiar with them from your use on your laptop. It's the folders and files that you have that's storing all your data, your documents, your scientific work. And what we're going to be talking about here is the actual how that data is stored on the supercomputer. So you might be familiar with some different types of file systems. Linux uses ext4 and a number of other file systems. Apple, APFS, Windows, NTFS. So those are sort of the underlying file systems that are storing your files and the protocols they're using to store that information. There's also different media that the files are stored on. There can be spinning magnetic disks or hard disk drives, as well as solid state drives that are sort of storing the data in chips or devices. So in the supercomputer, it's really important that we have file systems that are designed for performance. When you've got the thousands of nodes that you saw Christian talking about, and you've got a parallel program that's running on all those nodes that's needing to get access to data, you have all these instances of a program all pulling in data all at the same time. And so you need to have a very large parallel file system to facilitate getting that data onto the system, or else you'd spend all this time waiting on data movement and not any time actually doing the processing. And so because of this, there's different types of file systems on the supercomputer that have been designed specifically for different use cases. And in order to encourage people to use the right file system for the right use case, to make use of those different design parameters, there's different policies that we have around the usage of the file systems as well. One of the big differences between the file systems on the supercomputer and the file systems on your laptop is that you're sharing it with a lot of people. So on your laptop, it's just you. On the Photonics, we have hundreds of projects, thousands of researchers, and that can create some issues sometimes because modern file systems are designed to handle millions of files, but when you have hundreds or thousands of people with millions of files, you end up with a lot of files, and that can put load on the file system. And so you might see us talking about having quotas to limit the number of files to try and limit the impact that has on these large shared file systems. So here are the main file systems in Photonics: Scratch, Software, Acacia, and Home. And I'll be talking about each of these in a little bit more detail. We also do have some file systems dedicated to the radio astronomy communities. Pawsey supports the ASCAP and MWA radio telescope, and is also working with SKA. And we do have some of the data processing on our systems here. So I guess starting with the biggest, we have the Scratch file system. And so this is for all of the data that you're working with, your scientific data. It's a very large file system. We've got a 9.8 petabyte total capacity. And we have fairly generous quotas in terms of how much data that you can store there in terms of the petabytes, and also millions of files. So the capacity is per project, and the number of files is per user. And when you're on the system, this file system is available in this /scratch directory, and we organize the directories in that Scratch directory by your project and then by your username. So if you're just on one project, it'll be your Scratch, your project ID, and then your username. If you're on more than one project, you'll actually have a Scratch directory for each project. So for each project ID, you'll find you have your own Scratch directory. Now, historically, we had sort of more restrictive quotas on Scratch. So everyone got their own little bit of chunk of Scratch. And what we found is that not everyone would use all their quota at the same time. And what has happened in supercomputing centers is there's been a transition to having much more generous quotas. So everyone can use a lot of Scratch, but instead we have this purge policy where if you don't use your files for 21 days, we have a script that runs through and we'll delete them to free that space up for other people. That can be a little terrifying if that's your scientific data, because it will just disappear, right? So there is an onus on you if you're using Scratch to make sure that you're moving your data, once you're finished with it, off of the Scratch file system and having it stored somewhere else. And if the data is important to you, you have a copy of it somewhere else as soon as possible. And yeah, I guess whatever you do, don't do something silly like put your only copy of your PhD thesis on Scratch. You might laugh, what's happened. So if you're going on to do papers, PhD work, definitely have lots of copies in lots of different locations. So the next storage I'm going to talk about is something that is slightly more longer term. So this is our Acacia object storage. And this is uses an S3 interface. So object storage is a little bit different from the traditional file system that you might be used to. And so you have keys for storing all your data in these buckets on this object storage. And this data is actually accessible over the internet as well if you want to set the permissions for it. So it's a great way of also sharing your project data or your research data with other groups. So this is a place where you can store important data that you don't want to have deleted for the duration of your project, and you can stage it onto and off of Scratch as needed, and also sort of share that data with others more easily. And so by default, most projects have a terabyte of Acacia object storage, and you can relatively easily apply for up to 10 terabytes if you have a reasonable use case. And if you are doing work that requires more significant amounts of data, then we have a separate application process that you go through to ask and sort of provide a justification for why you need to use it. Sure, why my slide's not changing. Here we go. So in addition to your data that you're working on, there's also the software you're using to process the data, and that needs to live somewhere. And so we actually have a dedicated file system for the installation of your software, imaginatively called /software. And so this is very similar in nature to the design of Scratch, but it's smaller and more modest. And we have quota limits of 256 gigabytes per project and 100,000 files per user. And this is organized in a similar way to Scratch. It starts with /software. One thing to notice is that there's also that additional projects in the path, and then your project ID and your username. And so we also have environment variables to sort of as a shortcut to your default project, which is useful if you're only in one project. And so $mySoftware will get you to your software directory. And likewise for Scratch, there's a $myScratch. And for the data in software, it's there for the lifetime of your project. That 100,000 files can sometimes be an issue. If you're using a software ecosystem that creates thousands and thousands and thousands of files as part of its build installation, then you may find that becomes an issue. And if that is the case, we recommend putting your software into containers that we'll be talking about a little bit later on today. Finally, there's the home file system. So this is a traditional location in Linux systems where you would normally put a lot of your files. On the supercomputer, this is because we have those large specialized systems for storing your data and storing your software that are designed to be read from lots of nodes all at the same time. We recommend using home for as little as possible. So you'll find that there's configuration files for the software you're using might have normally live in home. And if you find that you're starting to hit those limits, then you generally look at your software and find ways to move it out to software to store those configurations. This is where you typically start when you log into the supercomputer, and there's a /home and then your username in terms of the directory path. One thing that we find researchers tend to do is you can set up login scripts so they automatically get executed when you log into the system in your home directory. And this is actually not a great way to set up your workflows because it means that anything you do is reliant on the stuff in your login script. So if you take one of your job scripts or your Slurm batch scripts that we're going to be talking about later and give it to a colleague, they're not going to have the same login scripts as you. So if you are wanting to sort of set up things automatically, we actually recommend having that in a separate file that you read in from your actual job scripts that are running on the supercomputer, because that way when you take your job script, you can really easily hand that to someone else and it'll do the same thing for another person. So we recommend keeping your setup as default as possible. Right, so how do we actually have a look at the file system usage on Photonics? We can use the quota command for the NFS file, the home file system, and the for software and Scratch, there's the Pawsey account balance that you can try, or you can query the Luster file system that sits underneath software and Scratch directly. So it's worth keeping an eye on or having an idea of how many files you're creating and how much capacity you're using, just to, I guess there's two main reasons for that. One is so you're aware of whether you're going to hit those limits. And so occasionally you might find your job gets halfway through its simulation and then it just stops because it's trying to write the output to the file system and you've hit a limit. And so then you have to go back and move some files off or reevaluate your workflow to get that working. And the other reason is that if you are wanting to get sort of large allocations on the supercomputer, one of the things you have to do is describe the workflows that you're planning to be using that allocation for. And so having a good idea of the amount of data that your workflow works with and produces means that you're going to give the reviewers of those applications confidence that you have a good understanding of how to use the supercomputer. So here we have some examples. I might go to the shell and we'll have a look at some of them. That's not working at all. So I'm on a Windows laptop, so I'm using WebExterm. We saw SSHing in earlier. Hopefully you're still SSH'd in. I'm just SSHing my username at photonics.pawsey.org.au. My password hopefully correctly. Got that to the day come through. So now we're talking about those quotas. So I can do a quota -s, and feel free to follow along if you're interested. So this is going to show me the quota on my home directory. Do I need to make that a little bit bigger? I probably do.
Yeah, if that's possible, just to make it a little bit bigger.
Sadly, I'm yet to find the hotkey for on.
I think that's good.
Yeah. So what we can see here is it's showing our quota for home. You can see I'm using 144 megs of my gig of the capacity on home, and I'm using a bit over 1,000 files of my 10,000 file limit. So another command, Pawsey account balance. So just using tab completion to fill that out. Pawsey account balance, and with a -s. That's going to include storage information. So that's now going through and looking at all the jobs that have been run under my default account. Once that comes back, it should give an output of the usage of the projects, and at the bottom, a usage of the storage. At the bottom there, it's providing for both Scratch and software. I'm using, is that one, a bit over a terabyte Scratch and 10 terabytes of software. And so this is the group that a lot of the sysadmins and our team uses to do a lot of the configuration work on the system. So we then also have querying the LFS directly with these LFS quota commands. We go those as well. We're going to use LFS, short for Lustre file system. We're wanting to query a quota. We'd like to be human readable. That means it's going to put the G for gig and the M for meg. And let's say look at our group. So there is an environment variable, Pawsey underscore project. That will be your default project, or you can just type in if you know the name of your project. Then just look at Scratch. So this is my group quota. So you can see Scratch, we've used 1.8 terabytes out of a 1 petabyte limit. And you can see we've also got a number of files there, but we don't have any limit set there. So it would appear that we're over the limit. But the quota on Scratch for files is on a per user basis. So I'm just going to change this to -u and my user. Just type a username there. And you can see now there's that limit, which I think is at 1 million files. Oh, and you can do the same commands for your software as well, if you're interested. So that's how you can get an understanding of how many files you're using. It can be useful to run those commands before and after you run a job to see how many files have been created. So that's, I guess, covering off the different file systems. So you want to stage your data up onto Scratch for use on the files on the supercomputer. If you need things, but you've got to remember Scratch, things get deleted. So you want to be staging things to and from Acacia for things that you need to hang around for a little bit longer. You've got /software for installing your software installations. And also /home, where you want to keep just configuration files, and more or less that's it. So let's switch over to the next module, or should we have a break? Okay, well, but the next module is not too long, so maybe let's keep going.